Hello everyone. This model incrementally loads data by only processing records from the AppData events table that have an event at timestamp greater than or equal to the last processed date. Incremental data load using the row key as a unique key and incremental key as a last process date from target metadata table. This process useful when you don't have primary key in a table. It logs the start and end of the process in a metadata table using pre-hook and post-hook macros. The main query calculates the number of daily active users and generates a unique row key for each day's data using a hash function. The row key serves as the unique identifier for merging new data into the existing table during incremental loads. See this. Configuration. Materialized equals incremental. This tells dbt to build this model as an incremental model. It will add new data to the existing table rather than rebuilding the entire table every time. Unique key equals row key. This specifies the unique key for the table, which is used to identify and merge records. In this case, row key is used as the unique key. Pre-hook and post-hook, these are SQL commands that run before and after the model execution, respectively. Pre-hook equals insert metadata log, inc for WTPK, inc. This macro logs the start of the incremental load process in a metadata table. Post-hook equals update metadata log, inc for WTPK. This macro updates the metadata table with the latest process date after the model execution is complete. Then next. SQL query. CTE, common table expression, named base. We select date trunc, day, event at, as date day to truncate the timestamp event at to the day level, giving us a date without time. User ID is selected to identify users. The from clause references another dbt model or table AppData events. The where clause filters records to include only those where event at is greater than or equal to the latest date from the metadata table, fetched using the latest date model, inc for WTPK, macro. Then next. Main query. Date day, the date for the event, truncated to the day. Count, distinct user ID, as daily active users, the count of distinct user IDs per day, representing the number of daily active users. Hash, concat, date day, count, distinct user ID, as row key. This generates a unique key for each row by hashing the concatenated string of date day and the count of distinct user IDs. This row key is used as the unique identifier for merging records. Group by date day. This groups the results by date day to aggregate the counts of distinct user IDs for each day. Then next. Step 1. Setting up the metadata table. First, we have a metadata table named target object which tracks the status of our data loading processes. This table has columns for ID, table name, type, and date loaded. Here's what each column represents. ID, a unique identifier for each record. Table name, the name of the table we are tracking. Type, the type of operation or data. Date loaded, the last date when data was processed for the table. Before we start our incremental load, we need to update this table to set a baseline. For example, we set the date loaded value for our inc4wtpk table to a specific date, like 1900-07-0410:00:00. This ensures that our initial load will process all available data since this is an old date. Step 2. Running the initial DBT model. Next, we run our DBT model. Here's what happens during this run. Pre-hook operation. Before the model starts loading data, it logs the start of the process in the metadata log table using a pre-hook. This helps us keep track of when the incremental load began. Incremental data loading. The model then executes its main logic. It fetches data from the AppData events table, filtering only the records where the event at timestamp is greater than or equal to the last date loaded date from the target object table. Since we set date loaded to 1900-07-0410:00:00, all records in AppData events will be processed during this initial run. Aggregating data. The model calculates the number of daily active users by counting distinct user IDs for each day, day. It also generates a unique row key for each record by hashing the concatenated string of date day and the count of distinct user IDs. This row key serves as the unique identifier for merging records. Post-hook operation. After the model finishes loading data, it updates the target object table with the new date loaded value using a post-hook. This ensures the metadata table reflects the most recent processing date. After this initial run, we can check the status of our inc4wtpk table to see the processed data. Step 3. Inserting new data. Let's say we insert new records into the AppData events table. Record with event at July 13, 2024, 12:25 and user ID 76. Record with event at July 14, 2024, 12:25 and user ID 89. Record with event at July 7, 2024, 12:25 and user ID 100. Step 4. Running the DBT model again. We run our DBT model again. Here's what happens during this run. Pre-hook operation. The model logs the start of the incremental load in the metadata log table. Incremental data loading. The model fetches data from the AppData events table, but this time it only processes records where event at is greater than or equal to the last date loaded value, which was updated after the initial run. This ensures only new or updated records are processed. Aggregating data. The model recalculates the number of daily active users and generates new row keys for the new records. Post-hook operation. After processing the new data, the model updates the date loaded value in the target object table to reflect the latest processing date. Finally, we check the status of our inc4wtpk table to see the updated data, which now includes the newly inserted records. Thanks for watching the video.